Hello, good morning, everyone. Welcome to this session of the Data Week. We'll be now sharing my short introductory slides. And again, I definitely welcome you all to this new week of the Data Week 22. And with this session, a matter of quality data for trustworthy AI in the manufacturing sector. Today with me, there is Sergio Gusmeroli. We are the chairs of the Smart Manufacturing Industry Working Group in Big Data Value Association. Let me just spend a couple of words on that. That's one of the vertical working groups in the association. We are living for a quite long time now, and we are focused on exchange views. We are involving all the members of the association, many members, as you see there. We are a quite big family. We are more than 120 subscribed to this group, and we want to take advantage of all the knowledge that is collected among that group to share. And one of the main aims is to identify challenges that is related to data, AI in the manufacturing sector. Over the years, we have published a couple of papers, the first one in 2018 and the second one in 2020. They have been collecting, as I said, challenges, focusing on the dimensions defined in the research agenda defined by BDVA, and also thanks to the experience and to the project run by members, we have put together those challenges. We have elaborated on that, also some recommendations, and we have published for the public audience. During the recent period, we are working on other three dimensions: the AI, the artificial intelligence for manufacturing, the digital twins, and the data spaces. These are aspects very much related among each other. But today, we want to put at the center of gravity the quality of data that we make use to collect, to elaborate, and to create results also according to those three dimensions, but not only related to those. How data is seen is the raw material that we will use. So the results that we get from there are highly impacted by the quality of the data we will use, but not only about the data, the raw data, but also the processes that we will put in place for collecting those results. The questions now that should be, let's say, addressed are going to look at the data quality from different viewpoints. We will look at that from the technical perspective in order to identify challenges to be overcome. We will look at the business perspective to identify new business opportunities and business models. We will make use of the user perspective to identify needs and requirements. And finally, from the ecosystem perspective, we will address industrial agreements and collaborations along and across the different manufacturing value chains. How we will do that? We will do that thanks to this list of speakers today, but also thanks to the introductory speech that we will have from Carlo Lacanina, that is working at the Barcelona Supercomputing Center, but at the same time is also co-chair of the Fair Metrics and Data Quality Task Force at the European Open Science Cloud. So let me welcome Carlo on the stage. He will do the first speech, and then we will move fast to the others. The session is organized in this way. We will have Carlo now presenting, then we have the core presentation, and the second part of this meeting is a panel where we'll also use 3 quick Slido also for involving the audience that we have, and to comment and elaborate on the questions that we will, again, we will share over Slido. So, Carlo, please, I ask you to share your screen. Please. Hello, you are still muted.
Hello, thank you for introducing me. Do you see the screen?
Yes, I do. Not yet in presentation mode. Yes, now it's in presentation. Perfect. And then welcome, the floor is yours.
Okay, thank you very much for having invited me. So as said, I'm Carlo Cagnina and I co-chair the task force in Eos with Mark Wilkinson. So I'm here to start to set the context about data quality. And first of all, what is Eos? So the European Open Science Cloud. It's an ambition of the Eos is to enable a trusted, virtual, and federated environment in Europe to store, share, and reuse digital outputs from research. So Eos is a pilot action for the science that will be fully articulated in the other sectorial data spaces defined by the European Strategy for Data. EOSC itself has advisory boards, which are named task forces that are there for steering the program into identifying strategic gaps, areas of investment, and providing feedback on developments. One of those task forces is named Fair Metrics and Data Quality, where I co-chair it together with Mark Wilkinson, and it's made of different experts from different areas, ranging from biology, philosophy, computer sciences, climatology, and so on. So first of all, to set the context, we need to go to the main question. So what's quality? I try to give you the perspective from EOSC side. Okay, so for that, I like to start with an example which is more tangible. Really a basic example, like the purpose is having an informal dinner, which is fish-centered, and then I need to look for wine. So I go to my favorite online shop catalog, and I look for different wines, and I make my selection. I ended up with 2 bottles of wines based on acidity, body, and so on. What happened behind the scene is that there is a quality team which has given the information about the assessment of the wine characteristics. So we know acidity, body, tannicity, dryness, and so on. Those characteristics are there, and I'm looking at those to check whether they satisfy my purpose. So those characteristics, in this case, we can name our functional requirements, are functional for my purpose. Then, behind the scene, the quality team has also assured that the wine itself is fulfilling expected requirements, which are not specific of my purpose. We name those non-functional requirements, like, for instance, that the wine has not to be toxic, the bottle usable. So there are 2 aspects of requirements. And if the quality team knows exactly what is the purpose of the user, then the quality team will have to guarantee that the requirements are fit for purpose. But as it happens usually in a fair environment where the reuser is not known, so what is the purpose of the reuser, then what the quality team will do is to ensure that the non-functional requirements are met, so they are fit for use, and the quality team will be only able to provide information useful for the customer to make a self-assessment of fitness for purpose. Like in the example, I make a self-assessment of the bottle that best suits my purpose. Okay, so first point, what is the mission of the quality team? The mission is to ensure the fitness for use so that the non-functional requirements are met. Then the quality team will have to be sure that information about the product they're needed to understand it and to use it properly is available. Third point, the quality team will have to ensure that the product is fit for purpose so that the functional requirements are met if the purpose is known. If the purpose is unknown, which is typical in a fair environment, then the quality team will make available the information to guide the users in the selection process so that the user can make a self-assessment of the fitness for purpose. Okay, so we understood what is quality, and now let's see how it adapts to the data sets. To start with, I like to go through the different components of a data set. So we have the data, so the facts that are collected, and then attached to the data, we have in the file information that we name metadata, which tells us, for instance, how the data have been structured according to a specific model. Usually there is a community standard we have to make such a model. Then beyond the metadata, we have external to the file documentation, which tells us additional information like what is the point of contact for this data set, how the data have been collected, and so on. And then there are also processes like how the data will be archived, what is the policy for archiving. Finally, the data set need to be moved through any system, infrastructure, or a network. And for this, there are aspects that we deem as quality, like security, portability, which are more important in this aspect of infrastructure moving of the data set. While before, when we look at the data content itself, we are more interested into aspects like accuracy, completeness, and so on. We can make again the parallel with the wine to say, okay, the wine content in the bottle is the data. The stuff that attached to the bottle tells us acidity, body, and so on, is the metadata, which tells us the characteristics of the wine. And then there are additional documentation, like what is the processing history, or what are the assets that have been used for productions. And then the wine bottles need to be moved to the customer. And so here again, we care about the portability, security, and so on. So there is this parallel between the two examples. Okay, and this helps us to categorize quality for the different types of assessment. So there is the most typical assessment about quality, which looks at the data content itself. In some disciplines, is known as scientific quality. So we want to check that the data resembles the reality, for instance. But there is more. There is technical quality. Like, for instance, we want to be sure that the data are structured according to a community standard or metadata, or the data are given in a certain format which is friendly for the users. Also, we want to guarantee that there is enough information about how the data have been collected, what are the processes behind, and so on, to make clear the context of the data set. This is the stewardship quality assessment. And then there is another level which tells us, which guarantees that the data are given to the right people, the confidentiality, they are secure, and so on. This is the custodianship quality. So there are different types of assessment in quality. Some more depend on the data, and some more dependent to the system where the data travel. This comes from the ISO 25000 categorization. Okay, so we understood what is quality, how it adapts, and now why quality, and what are the quality dependencies. All right, to this, I need to introduce you the concept about the barrier between supply and demand. And typically we have users on the right-hand side here, and then we have a product. In this case, we have a chicken. And in the middle, there is usually a barrier. Here, the example of the barrier is a fence. So the users need to reach the product, and the quality team will be there to remove or reduce as much as possible the barrier in between, so to guarantee the usability of the product. And then the quality team will also have to guarantee that the product, the chicken in this case, is not poison, is not dangerous. So it's reliable. In the case of the data set, that makes sense, the data set basically, that the data are reasonable, or if or the format is according to typical standards. So it's usable, the data set itself. Those two pieces, reliability and usability, again, are the fit for use aspects, which are independent of the purpose. But then even though I reach the chicken and I find out that I'm just a panda and I'm vegan, so this product is not applicable to my needs. So the fit for purpose is not guaranteed. So those two aspects are important dependencies for quality, the application, fitness for use and fitness for purpose. Then we have the stakeholders. Indeed, there are many actors that are benefiting from having data of a certain quality. ranging from users, providers, service, and funders, and all need to be involved in a quality assessment, which is a multi-actor process. For instance, for the users, you need to involve them because you need to harvest the requirements that they need to be fulfilled for your product to be useful, valid for them. Data providers also need to be involved in the quality assessment because even though they benefit from having data of quality, they also are the one in best in place in knowing the details of the data set. So there is every of the stakeholders need to be involved in this assessment of quality. And remember always that in this assessment that can be as much complex as possible, there is always necessary a cost-benefit analysis to understand to which level of quality we want to reach, and this is necessary for the different stakeholders. The third dependencies in quality is the dataset lifecycle. When you are in a dataset, when you are at the beginning, when you are just collecting data, you might be more interested in checking that the data that you are collecting are resembling as much as possible the reality. So you are looking at the accuracy. But if you are in the end of this life cycle where you are serving your final dataset product, you might be more interested that your dataset is complying with community standards, that is usable. For instance, the format is the most typical for the users. So depending on the different stages of your dataset, you might be more interested in a certain quality dimension, accuracy, or another one, accessibility, for instance. Okay, so those are the three main dependencies in quality. Take-home messages. So quality is no more than the degree to which a set of characteristics fulfills requirements. This comes from the ISO 9000 family. Then not all the aspects of data quality are purpose dependent. So the whole concept of fitness for purpose needs to be adapted in the fair environment. Not always the purpose is known. So the quality team has an additional mission, which is fitness for use. Quality is not only about data content, which is sometimes known as scientific quality. In quality assessment, we look more than just data content. We look also how the data is served. Technical, stewardship, and custodianship quality are also important dimensions. And then having data of high quality is beneficial for several stakeholders. But remember always to make them all participate in the assessment, which is a multi-actor process. And finally, the third dependencies, depending on which stage of your data set you are in, you are more interested in certain quality dimensions rather than others. Okay, with this, I hope I managed to set the context for more detailed experts talks. Thank you very much.
Thank you very much. Thank you very much, Carlo, for your talk and for the very clear example that you have used. I have to say that the parallel making use of wine is being very, very appropriate. I've used very quickly the coffee beans. You have used the wine, so we are definitely aligned also with the food examples. Thank you very much with that. I hope that has been very interesting also for our audience. I welcome now on stage Nenad from Nisatech that will start to deep dive on the topics that we are preparing, that we are presenting, and he will start from a more technical approach, looking at methods and tools for data quality. Nenad, 3, 2, 1.
Can you hear me and see me? Yes?
Yes, perfectly.
Okay, thank you. Good morning. Hello to everyone. I'm presenting, as David said, a little bit more technical stuff. The story is about tools and methods for achieving data quality, as Carl was explaining. And this is the agenda. I will, first of all, very briefly try to explain what is the role of data quality in manufacturing. Then I will explain general data quality pipeline, some extensions. Then I will introduce something new. This is A-based process-driven data quality. And I will also present the tool where we are implementing this from the A-Regio project. And as you can see from the background of the slides, everything is related to the A-Regio project. Manufacturing and the data. We all know manufacturing and all other industries are producing a huge amount of data. Now, the role of this data is usually that you are building some models. And these models are used in some applications. In the manufacturing, there are billions of applications, but more or less they are related to the monitoring, first of all, monitoring quality, which includes also anomaly detection, which includes also predictive maintenance. Now, what is the issue? The issue is if you have bad data or data of the bad quality, you will have the bad model, and then you will have obviously bad applications. Garbage in, garbage out is a traditional problem, we all know. But if you're talking about data quality, this is usually related to kind of data processing pipelines, which consist of several steps: adaptation, profiling, cleaning, preparation. So there are plenty of different types of these pipelines, and all of them are obviously doing this iterative, but I would say improving of the data, so that if you have some issues like missing values, you can fill into these missing values by using different algorithms. And you on the figure you can see two of them which are applied, and probably most of you are very well known about this. What is the issue is if you're talking about models which we have to produce, usually we are talking about model of the normal behavior. Because if you have your manufacturing system, obviously with your data, you would like to model normal behavior of this system in order to monitor how it is working, or is it working properly, which implies that the data we have should represent normal behavior. Now, what does it mean, normal behavior? Usually it means that it is an anomaly-free data set, which is producing model of anomaly-free behavior, not bad, which means that actually in the data processing, we have to have something like anomaly detection. So you have your data set, you do anomaly detection, then you get anomaly-free data set, and you learn the model, which is anomaly-free. But this is ideal world, because in this case, you have data which is reflecting something like your ideal production, which is also not bad, but there are, first of all, two issues. Getting anomaly-free data set means that you have to introduce mechanism, as I said, anomaly detection. Usually it is supervised or unsupervised. If it is supervised, then you need domain experts who will be labeling your data. If it's unsupervised, you need a very strong algorithms. Then these models are less resilient, meaning that if you have anomaly-free behavior or model for anomaly-free behavior, you cannot react on anomalies properly because you don't know really what are anomalies. You know only what are not anomalies or what is really, let's say, normal behavior. If we talk about models, this is something that I'm using from this guru of the digital twins, Mike Graves, who actually developed this systematization of the system behavior into predicted and unpredicted, and you have predicted desirable and unpredicted undesirable, as you can see on the screen. And model of anomaly free is only covering this left-hand one, so this predicted desirable. And this is actually, I will not say easy case, but this is the case which is not covering unknowns. So this is what I said with less resilient. So if you have this kind of the modeling, then you cannot react on unknowns. And what you need in order to react on unknowns is to model all these other type of the behavior which are now related to the process context. And now back to the data quality. Data quality means now that if I would like really to make really good models for my system, and actually the main goal of the data is to serve to the models, as we have seen. So data per se, they don't have any kind of value. They have a value because they're applied in different kind of algorithms. So you can share your data and earn money probably, but let's talk about applications. So what we are saying is that if you would like to model system behavior, including also other cases then not only anomaly free, then you have to introduce the process context. So this is now another very interesting element also for data analytics in general. Usually we say data is there, okay, and then we apply some algorithms, okay. But we are forgetting that data is coming from a process context. Data is not, especially in the manufacturing, data is not coming out of the blue. Data is coming from the process. Usually these processes are very stable, they have capability, they have some properties. So we cannot say just data is there. We have to say data from the process X is there. So the process context start to become extremely important, especially if you would like to handle a situation like not anomaly-free data models, which lead us to actually an extension of the data quality pipeline, which we call process-driven data quality pipeline, which introduce the notion of the process context in order to resolve some issues. Just look at this slide. You see here something which we call outlier. It's obviously an outlier because by assuming that the process behaves normally and then there is a huge increase in the value of some parameters, then you say this is really an anomaly. But is this bad or good? because some anomalies are usual, because you have your process, which is, by the way, we are not calling them anomaly, we are calling them outliers. Some of the outliers are usual. So without having the process context, we cannot say now is it usual or unusual. Should we exclude, even worse, should we exclude this from the normal behavior, or we should include? Because sometimes normal behavior includes also your anomalies, because some of the anomalies are normal. And then you have to learn the model with these kind of anomalies. Okay, process context is very important. And this leads us to the, let's say now, technically speaking, contextualization of the process as we are doing in iRegio into 3 dimensions. First of outliers, which are variations. And there are stability, which is related to the process characteristics, and third are process unusuality. So I'm not going now into details, but just imagine that now by using this context, we can say that this kind of behavior is actually usual behavior, and we should not exclude this when you're learning the model, because this is normal behavior of the process, but including also anomalies. Now, this led me to the whole picture, or the big picture, how we see now the data quality. It is A-based, process-driven data quality. So data quality and high data quality comes with a price, and the price are actually 2 things: process context, and then AI techniques or AI-based techniques, in order to see how this process context can be used. And that's what you can see here is our general pipeline. So on top of data pre-processing, which is set of the methods, as I have shown in the beginning of the presentation, by extended with some AI methods, or we will see now in this slide, these methods are combination of statistic-based methods, which are related to the process stability, because process stability is statistical categorization of a process. You see some formulas. Process outliers, which are actually a combination between statistics and machine learning, which is called statistic learning, because the outliers or variations are depending on the statistic, but also can be learned. And then unusuality are really hard artifacts. So what is unusuality? Unusuality detection can be detected only using some kind of artificial intelligence. In this case, we are using autoencoders in order to do this unusuality detection. So now this is the portfolio. So we have this kind of the methods which are applied on the data. These methods are coming out of the process context, and everything is implemented into a regio, it's called Data for AI platform. Data for AI platform is actually the platform which ensures this AI-based high quality data for AI applications. And I have only one slide. It's based on the stream pipes, because all these pipelines obviously should be orchestrated in a way. I'm showing here one of the pipelines which is actually realizing this generation of the models where we are including also anomalies. So this is not anomaly-free data modeling, but obviously I'm not going into this. Everything is open source, so it can be used. I hope that in the future we will have much more support also from the open source community. And this leads me to the very last slide here. It is a conclusion. What I'm saying is that obviously quality of the data is influencing quality of the applications. We can always do something with anomaly-free data sets, so we can always have ideal models, but this is leading to the problems in application of these models. If you would like to have more resilient models, then we have to introduce context. And if we have to develop this context, we have to generate this context, we have to use AI-based methods. We have implementation in a data for AI platform. And very last thing here is a new view. Why the data quality is very important. It's not only about garbage in, garbage out. It's also about if you have your data set and you are not cleaning properly, and then you are using much more data for learning that you need, then you have things like this. You see from this table that if you compare the energy usage of some NLP algorithms, whatever they mean, and the average consumption of the CO2 for a car for the whole lifetime, then it is comparable. So what we are talking about is, and we already know, that data centers and all this data processing is consuming an extremely huge amount of energy. And what I'm advocating is that by using this kind of intelligent methods, we can really constrain the data on useful data, so high quality data, and then obviously our algorithms will be trained with less data and using less processing power and consuming less energy. This probably will provoke some of the discussion in the panel, and that was the intention of this last slide. Thank you very much.
Thank you very much, Nena. Very impressive figures those you have presented in your last slides, and you really launched a very provocative discussion for the panel. I'm expecting we will get back on that.
Yeah, thanks. Thank you.
Thank you very much, and talk to you in a while. Now, next in the line, we have Feneretti, that we will also present us some emerging topics like the synthetic data one in manufacturing. So move on, just the floor is yours, and just share your slides. Okay.
Thank you.
Okay.
Thank you, David, for the introduction.
I hear you, and
you can hear me, but you don't see my screen on presentation mode, I think.
No, we just see a wonderful sea coast.
I need to stop sharing, I think, and start again. Sorry for that. Let me check again. Now it should work.
Yes.
Okay,
perfectly.
Great. Thanks a lot. Thanks, David and Sergio, for inviting me in this session. In the next minutes, I'm going to talk a little bit about the role of data in AI, and especially in manufacturing. We have heard so far the importance of data quality on what is the resulting models we get. And I'm going to provide some further hints and some further directions that are relevant to the synthetic data generation. It all starts with the fact that data comes in many forms. Data may be available in different formats, through different sources, stored in different systems, stored in files in many different ways. But the conclusion we all get is that in almost all cases, the data are messy for different reasons. Lack of documentation, lack of metadata, lack of structure on the data, missing values, different frequencies on the data that are not appropriate for further analysis. We all know and we all acknowledge that our models and the models we create through AI are as good as our data are. The AI models we are creating are driven by the amount, the quality, the speed of training data we utilize. It does not affect the application of the models we have created, but the predictions we get and the results we get, the decisions that are proposed by an AI system are dependent on how well it has been trained on different occasions and on different edge cases. One of the main, let's say, trends that have arisen over the last years are synthetic data that are computer-generated data, data that are not real, data that do not come from direct measurements or real values, but data that have emerged in order to address problems we had with data, missing data that are not on appropriate volumes or of appropriate quality. Perfectly labeled data can be created through generative AI applications. And although initially it started as, let's say, the next steps, how data augmentation works, data augmentation in order to address data anonymization challenges, right now it is utilized on many different cases for training AI systems, especially in computer visions, when it comes to robots, when it comes to autonomous vehicles. In manufacturing, there are different cases that one can see, different cases and different experiments that have been executed in robots within the shop floor, or experiments that have been performed in order for robots to identify different textures, different lighting conditions within the factory that it's not easy to obtain without such data. For many people, the future belongs to synthetic data. There is a certain limit that we are soon reaching with the real world data. Synthetic data will give us the chance to take the leap forward towards really enabling many more use cases than we can right now purely with the use of real data. The process of creating synthetic data, in most cases, when we're talking about fully synthetic data, partially synthetic data, or hybrid data, it all starts with real data or some rules, some assumptions that are following certain processes, either data-driven or process-driven, in order to create the synthetic data. In order to understand the extent to which the synthetic data are fit for purpose and are really adapted to the needs of the problem we are trying to solve, a utility assessment needs to take place in order to understand to what extent the data are representative of all the cases we are trying to predict, we're trying to anticipate. Another aspect that is quite critical, since we're talking about synthetic data that may come from personal data, from different data that are confidential and should not be exposed in any way, different privacy assurance techniques can be also applied on the synthetic data in order to ensure that the outcome that has emerged cannot be traced back to the original real data. Synthetic data can be generated from real confidential data sets, from real public data, from an existing model, and with the use of simulation engine, it can be used based on the knowledge that a data scientist, a person that knows very well the domain, has, and tries to recreate certain conditions and certain aspects of the problem he's trying to solve, but also specific assumptions that can be generated and try to provide further insights on the phenomenon we're trying to observe. Depending on the type of the synthetic data we are creating, its utility obviously varies, and this has impact on the AI models that are created as an outcome. The benefits are more or less self-evident. With the use of synthetic data, with the use of generative AI to create such data, we can address the demand that data scientists have for large amounts of data, data that are representative, data that are don't have missing value and have high quality. And such data can be utilized to properly train different AI, different machine learning models. This can be done in a timely way, in a few hours, without requiring a large, let's say, time to observe a certain phenomenon in order to manage to generate a respective model for solving a specific problem. If we want to narrow down the benefits in three core dimensions, we start with the fact that we can address the cold start problem. It is very, very frequent when we're talking about new factories that are opened, a new product that may be manufactured, a new process, something that has changed, and the manufacturer does not have access to real data, or the available training data are little, sensor data that have been just installed on the factory, and we don't have adequate data to start building our problems. Another aspect is that it may be the case that we have a certain amount of data for 1 year, 2 years, but still there are edge cases that are not encountered within our data. When we talk about predictive maintenance, a machine may break every 3 years, every 5 years, and our data do not have such situations. So in order to predict the rare edge cases, we need some kind of simulation, we need some kind of synthetic data to help us properly train our models. Last but not least, when we try to train a robot on the shop floor, and there are real humans, actual people. We're not allowed to take photos to utilize the real, let's say, material. We have restrictions related to data privacy, to compliance with GDPR when we monitor human activity. And here, synthetic data can also help. In XMANI, we are addressing synthetic data on a slightly, let's say, in an early stage, I would say. XMANI, first of all, is all about explainability, explainable AI by design, bringing it at the level of data, at the level of models, and at the level of results. And in the different pipelines, we allow the data scientists to create, and you can see here an early screenshot of our platform that is still ongoing. The data scientist can define different pipelines and can define different data preparation techniques that should be applied over the available data. We have opted to create synthetic data, not when the data are checked in, are uploaded by the manufacturers, but at the data usage time when the data scientist wants to utilize the data, and they are based on real confidential demonstrator data. And the technique we are following is data imputation. So it is a data-driven technique that will help us handle different cases, starting from resampling to simple cases, filling missing values or grouping certain data. And the drivers we have for including such techniques on the pipeline design is the fact that for certain demonstrator, we have little training data in certain cases. In other cases, it is GDPR compliance. We cannot have all the data since they refer to real individuals. To conclude, synthetic data are here to stay. They must be created based on the actual problems and the needs of the data scientists. They must be fit for purpose. It cannot be synthetic data for any application, but still there are different technical challenges that are encountered when we are trying to ensure high quality of synthetic data, depending on the starting point we have. It is, in a way, an underrated technology. Many manufacturers and many industries have not yet appreciated the benefits it can bring, and we need more education in order to understand the benefits one can get from such a technology, and to also, through training and through education, to assuage the concerns that models built with synthetic data are not as good as the real world data. So thank you for your attention. I hope I stayed on time.
Thank you. Yes, of course. And thanks to you as well. So you will be also taking part of the panel that we will have in the second part of the session. And also thanks to you, we understood also now how important is synthetic data in addition to real data. Now, looking at the both kind of data, one thing that is maybe considered in common is the importance to know where those data comes from and how it was elaborated. So data provenance, data traceability, and this is introducing the next talk we are going to have now. I invite John Soldatos to join, to share the screen, because the topic of data provenance and data traceability is really at the core of his talk. John?
Thank you very much, David and Sergio, for this interesting session and for the very good introduction.
Thanks to you for joining. Yes.
So yes, let's talk about the data provenance and traceability, and why this is important for the data quality, but in general for trusted artificial intelligence in manufacturing. And this is work that is happening in the context of European project STAR that net company Intrasoft, my company, we are coordinating. And it aims at providing trusted artificial intelligence technology for industrial applications, manufacturing in particular. And one important dimension of trust is to get your data right, to ensure that your data are trustworthy. And it might seem obvious, why do we need to have reliability and provenance at the data level? But since last year, there is another good reason. For those that have browsed or read the AI Act of the European Parliament and the Council of Europe, you will see that we have there a risk-based approach to the classification of artificial intelligence systems. It is this pyramid that you see there, and the AI Act invites deployers and operators to classify their systems. And for high-risk systems, and we have high-risk systems in production lines. You can imagine human-robot collaboration or systems that they are taking critical decisions. For those cases, then data quality is one of the preconditions in order to deploy your system, in order for your system to be allowed to be regulatory compliant, and when this becomes a law, to be legal. So that's another strong reason for having high data quality and, of course, high robustness and cybersecurity. Explainability that is touched upon other presentations is another requirement for high-risk systems. What you see on this box on the right. And then what's the problem with industrial data? The problem with industrial data, I think Fenaretti explained that you've got data silos and they come from different sources and it's difficult to build to put them together. But I would like to add they are inherently also unreliable industrial data because of environmental influences like temperature, background noise pollution. Imagine we have, for example, acoustic data or ultrasonic data using for asset management, or even some problems, some inaccuracies or faulty sensors, maybe problems with the power efficiency of some systems, the battery, and of course, cybersecurity interventions and attacks. So there are many reasons why industrial data cannot be trusted at the first place, and there you need to have you need to be careful when you collect this data in order to be trusted. Also, there are a lot of cybersecurity issues and cybersecurity attacks like evasion attacks or poisoning attacks, in general attacks where you can fool an AI system so as not to be able to classify correctly. And in these cases, data has to be reliable. If not, your AI system can be compromised. So for all these reasons, we one of the systems for trusted AI developed in STAR project is a data provenance and traceability system, so that you are able to trace the source of the data, and once you get your data there right and reliable, you are able to identify any attempts, for example, to change or to tamper the data after it, or even to identify that at a later stage of your AI system development, the data is not right. Now, we use this, for this a blockchain approach, a distributed ledger technology. We know blockchain technologies, they have pros and cons when they are to be used in industrial environments. There might be a good application for data reliability because of some properties of the blockchain, especially when you have different parties managing and writing on the data that do not necessarily trust each other. This is a classical use case for a blockchain, a permission blockchain in this case. And indeed, when you've got an environment where a manufacturing environment where different parties from different trust domains, this can be a supply chain, but also to simplify things, different applications inside your shop floor. So when they touch your data, and when you add also AI applications, you've got different trust domains, reading and writing the data. And this is a good idea for using a blockchain technology to make sure to benefit primarily from the tamper-proof property of the blockchain. So once you write something on the blockchain, that's it. It can never be changed. So that's a good way for tracing the source of the data. Of course, we are not the first ones to think about it. There are many systems like this in the literature, of course, for different uses, like ProvChain from Tennessee University in the US. That's more on cloud data traceability, but also in different industrial sectors for tracing product data. Now, this is our architecture for tracing the data. So the idea is that you get the data from some probe in your factory, you pre-process the data, and then the metadata about this data are written in the blockchain. So we've got all the metadata about a data set, including, for example, statistical properties, information about data volumes, and so on. So if somebody tries to change this data set later on, or this data later on in the process, you are able to confront the properties against the blockchain, and based on the provenance to trigger some alert or some high risk situation and so on. Now, one of our, so you've got somewhat in the star blockchain, you've got trusted and sealed data. Now, one of our value propositions that other systems do not do is that we don't do that just for the source data, the raw data, or even the pre-processed data. We also do it for AI algorithms. So in a sense, we have a seal on an AI algorithm if you want to use it, so that it is not also easy to tamper or to compromise, for example, some parameters of the neural network or the deep neural network that you are using, because these parameters are also written in the blockchain, and you've got all the metadata there, and you can check that your algorithm is right. So we've got provenance of AI algorithms, provenance of source data, and provenance also of AI analytics. So if your algorithms are trusted and your source data are trusted, then your outcomes are also trusted. Now, our implementation is based on a permission blockchain for reasons of performance and energy efficiency. By the way, this has been benchmarked, and the performance is getting better and better. So thousands of transactions, of data transactions per second. So that's a classical blockchain network that implements the data provenance and traceability and communicates with an API with the rest of the star systems, of the AI star systems. This is our probe modeling architecture. What is here is the pre-processing to get the data right, but also the use of a proper data model and data manifest, so as to persist the properties of the data. Now, once you do this, you unblock many opportunities for many different applications. So we use the blockchain to test that the data, to audit that the data are always right. So in this case, in this sequence diagram, you see how we use this for a cybersecurity use case. So defending a poisoning attack, when you have to retrain a neural network inside your factory because new data are available, that's a perfect opportunity for a malicious party to launch a poisoning attack. Now, if you check that the training data are the right data, so they have the properties that are written in the blockchain, you can really you can really issue an alarm and avoid a situation of compromise. So that's what I wanted to say about the data provenance and traceability using blockchain. You can read more about this in the STAR website. We've got a very rich collection of blogs and articles that are very simple to read and to digest. You will find tens of them on not only on this topic, but on the topic of trusted AI in general. And I invite you also to download our book that was published last November. It's got already 13,000 downloads, and it's open access, so that it means you have unlimited access for free. So I invite our audience to download it and read about blockchain for data provenance, but also trusted AI in manufacturing. And thank you for your attention. David, I'm done speaking. I guess the floor is for the next speaker.
I'm back. Thank you very much, John. Very inspiring as usual. And thank you for pointing out the importance of having for the trust that you have to put on data, not only for the data that you are taking from, but also for the data you have produced for, yes, for the risk that you may imply in making use of the data for critical applications. And but not only for that, it's very important to be sure about the data and the processes. You mentioned also about to be sure on the models that you are making use. So in order to avoid poisoning attacks and all these kind of things that will really hamper the results. And all these things are very important when you want to make business out of the data that you are producing, and of course on the data that you are consuming. And this will introduce us to the next talk. We've been looking at very technical aspects so far, and now we slightly move to more business-oriented issues and aspects, thanks to Stefano and to his talk. Stefano, I see you are already sharing, and the floor is yours. I don't see your slides anymore.
Yep. Can you hear me now?
Yes, I hear you.
The slides also?
I see the slide, and
right.
I hear you.
Hello, I'm Stefano Madafferi, and I work for the Innovation Center at the University of Southampton. Incidentally, I'm also the BDVA Task Force 8 on Business Model leader. And what I want to talk really today is trying to see how we can translate, or what is needed to translate these interesting solutions, technical solutions, and technical challenges that we have met in terms of making business. So this talk is really related to business models, which will need the technology underpinning that we have heard about even more. But then also the business models themselves needs to advance, and we'll try to look at that. So let's have a look at what we think is our blue skies and what is the reality. And the reality, I will give a small snapshot of what is in the EFPF project, which is about is an agile platform for manufacturing, but has distributed some cascading, lots of cascading funding. So has worked with innovation, around innovations with SMEs. And then what can mean looking at data, not just as something that you can use to make money, but as currency, as part of the core part of the equation. And what's the role of trust and trustworthy in this process? And then what could be the next directions for innovative business models? So we know, and we have been told many times, when that blue skies means that, okay, we will have at some point a stable legal framework for data sharing, for making business around data. We will have a technical framework. We have a technical framework. It's probably the aspect that is progressing more. And we know, and we have seen lots of projects and also work around how to manage the data sharing and making, doing something, working with data. Beside these three things, we know, and there are works around that talks about innovation culture and demonstrable benefit, which we'll see are the things that still needs to be pushed and explained to the community, especially the manufacturing domain. Anyway, if we have these five, more or less these five ingredients, we will magically, some innovative business model will appear. These are blue skies. What is the reality? Oh, now the EFPF has funded 20 projects as a project with 30 plus core partners, many industrial players, many SMEs, several academics, and basically is an interesting platform that provide lots of basic services doing the heavy lifting of what needed for working with data. So the approach has not been let's try to find good new solution, new technical solutions, but was more asking the companies applying for the cascading funding to come with real business problems and to have real business models that they want to address. And a total of 20 SMEs got access to this cascading funding, and have been a market-driven approach. They have basically they had to have this business problem attached with them. Have been evaluated on the originality, on the innovation of the technical solution, but having a business case was mandatory. Now, we have had a quick look at what's there, and 100% of them are data-driven, which is not surprising because we're talking of ICT companies, we are talking of this era, we are talking of scenarios where data are understood to be the main driver to make business. 100% of them, however, offer basically third-party services over data. This is very generic on purpose because what we wanted to look at is what are they trying? Are they trying something new, or are they just trying to make money with an established business model? And all of them are trying to make money providing services over data if they are an ICT, or paying services of their own data if they are industrial partners. If we drill down a bit on what they do, over 27 of them would do something around supporting better extraction of data, 8 about better manipulation of data, 3 about shared data. This is some of them were doing several of these categories. Some of them were extracting value or anyway information from the data analysis. 6 of them were providing collaboration solutions for enabling multiple actors to work around shared data, and 4 of them were doing simulation. So you see, there are ideas there which are different, though 40% of them was doing predictive maintenance of some sort. So predictive maintenance is the buzzword now, has been the buzzword for many years, and this is still one of the main way that companies see to make money with data in the manufacturing domain. But there are other aspects that are emerging in terms of what can be done or what is needed in real business case with data, but still the model is pretty simple. 100% of them is offering services over data. And we think that this is okay, and it's the way it is the situation now, but there are possibilities to move on that. So we asked also what were the barriers, and they perceived more or less all the known perceived barriers still existing, like technical, operational, and legal. But one of the main barriers has been also the lack of propensity to risk among their customers. So, for instance, there was one case, I will not make any name, in which an important European industrial company were happy to even have some trials, some proof of concepts on their own production lines with some solution. But eventually, when they said, okay, can we now go to the next step and make it operational? They said, no, it's too risky. So this type of innovation and culture, of which Oscar will talk us in the next talk, is something that needs to still be nurtured, because it's in reality at the moment probably the most difficult barrier to overcome, well beyond the technical challenges we are facing. So there is an opportunity for new business models or innovative business models, but this is probably not right now, but in the mid or even long term, because there are still things to be done. One aspect which is important in business models in general and in data-driven business model is trust. Now, trust is a social and human-based factor, and you can't take away the human from that. All the socio-technical systems we live in, and basically everything that is AI-based is a social technical system, or almost all of them, will require some form of technology acceptance. If the human doesn't trust the technology, then there is no chance that technology will live long. And when I say the human, is not the single human which can take personal decision, but what I'm saying is in general, humans. But so to enable different type of business, especially in the culture I was talking before, you need to trust, and you need that the right stakeholders have trust in the technology. And it is important to distinguish between what is the objective quality and the perceived quality, like Carlo was kind of touching on in his own presentation. Because each stakeholder will have a different way of looking at quality. And according to the role, you need to make sure that that stakeholder, that group of stakeholders accept the technology, trust the technology, and can start using it or adopting it. And quality is one of the key that is needed to build trust, because no one would trust something where quality is not present, or is not enough, or is not perceived to be enough. So now, quickly moving to what could be next. These are topics which are have been explored by different papers or white papers around. We're working on this and in the task force 8. Some of them are around this simple idea. First, data is currency. So what do we need to not make money around the data, but have the data as money? And these put lots of also still technical challenge on how to enable it, but can be one direction to go as to enable new type of business models. Can we have cooperative approaches where 2 or more people can share, can share information, and the value of the combined information is higher, like federated learning or things like that? There are technical solutions, but the problem from a business point of view is understanding how to distribute the benefits according to these models. So how can we calculate that? How we can convince people that the model is suitable and is profitable when we go around this and beyond what I said, just the proof of concepts? Can we have peer-to-peer models? So basically, the technology provider, the data sharing technology provider, data space owner, to use a terminology that we are familiar with, could become, or will become, or shall become a commodity, such our, I don't know, backbone internet connection, so that then the data sharing and the business happens without a third party in the middle, but among individuals or among companies. And removing the third party would still require trust in the technology, but from a business point of view, it will be much easier. When we make a call, we trust the telecom not to have the man in the middle, but we just don't care that they could know what we're talking. Okay, there is the security part, but in general, if there's nothing too sensitive, we can discuss, and we don't mind if we don't even think that someone could hear us. I mean, if the security is properly in place. And other two quickly is one is we are in the manufacturing domain. This is true in the shop floor, and this model is probably even more important for physical customers around. But there is the world is full of devices that have small computational capacity. Can we have some business model based on the fact that I can offer my capacity, my computational capacity, for someone else while I'm not using it, and gain some benefit? Now, this is something that, as I said, at user level can be very fine-grained and small, but there are use cases which are at much larger scale, like one we've been involved with British National Railways and the British electricity company, which we are trying to do something like this. A final, working with data requires competence at many levels. Okay, can competence be part or be considered in a business model, or they need to be just something that you need to acquire, but then are not part of the equation? I mean, in the everyday equation in which we make business with data. These are all open questions, all open possibilities. It's, as I said, it's not today, it's down the line, but it's probably something worth thinking when we think about business models around data. Thank you. That's it, Davide. I don't know.
Thank you. Thank you very much, Stefano. And thank you for all the different open opportunities that you have presented. I guess that, as you have said, we don't have anything very established so far, and many opportunities are ahead of us, and they just need to be explored. I invite now Oscar Lazaro on stage, just to start elaborating maybe a bit on that with an example about data marketplaces. So Oscar, please.
Thank you, Davide. So
welcome, and floor is yours.
Thank you. Thank you, Davide. I guess you now see the title of the presentation that is basically trying to connect a little bit what is the role of digital innovation hubs with the development of these data marketplaces. I think over the last few presentations in the panel, we have seen that there is already a maturity and progress in terms of the different tools that we need to address the issue of data quality. But in this last talk, what I would like to focus is in the concept and the need to mobilize ecosystems. If we want to see all those tools and elements in actions, the business models, the technology tools, and so on and so forth, somehow we need to mobilize the ecosystems. And obviously, if we talk about European ecosystems, digital innovation hubs are a key instrument to support SMEs, which are a key stakeholder in the digital and vertical ecosystem. They actually account for almost 99% of our industrial fabric. Obviously, we are trying to materialize or to bring to operation what is the vision of these big investments that the European Commission is making on data. At the end of the day, what we would like is to have access to the different tools and to the right business models, so we can actually realize all these big impact that we have seen many times regarding the data economy. So we know for sure that the increase in data volume will be exponential. Actually, we don't need to look into the future. If we look into the past, a very recent analysis by the World Economic Forum basically revealed that 90% of the data that we are using today not only in manufacturing, but in other sectors, has been created in the last 2 years. So, so this is important since we are going to see this increase in volume. So it is very important that this increase in volume in terms of data is actually matching the quality of those data sets. So we can really realize the business models and the business opportunities that Stefano was mentioning before. So actually, there is a very big opportunity, and I think I don't need to explain in this forum what is the impact that the data economy is promising to deliver. Only with the new Data Act that was released by the European Commission very recently, we are expecting to increase by a huge amount of euros the value of our internal economy. But that is basically what or where we would like to be, and why we are making the connection with digital innovation hubs, testing and experimentation facility. Why are they needed actually when we discuss about data quality? What we see is that the reality today in terms of digital maturity, either if we look at the countries, the sectors, or the size of the companies, we see that the digital level and the digital maturity is quite uneven. And that could be a very important and significant barrier if we want really to accelerate or capitalize on all those nice technologies and business models that have been presented. If we do not manage to create some sort of critical mass of mature countries, sectors, and companies that can actually mobilize their data to create this economic value, it is going to take us much longer, or probably it will be most costly to realize this economic potential. So when we talk about SMEs, this is more or less what the type of triangle that we are trying to aim to. Basically, we have data, and with data, SMEs face two problems. One, I think it has been already discussed, is how do we access quality data sets? Could be real, could be synthetic, as Fenareti was discussing, but how to access these quality data sets, and more importantly, how we are going to create those quality data assets, so they can actually be presented and they can be reached. But the access to those data is not enough. We have to create the business ecosystem and the business opportunity to create value. In terms of digital innovation hubs and testing and experimental facilities, for those of you that may not be familiar with the concept, that I guess are not so many by now, but just to refresh a little bit, the Digital Innovation Hub is actually bringing many different actors and resources, most of the time around a particular region. So there is a local support of services for the digital transformation of the small and medium enterprises. And obviously, support of those SMEs in terms of how to generate these data sets of high value that they can be offered in the marketplaces, how the SMEs can access data sets from others to make this generation of the value opportunity, and at the end of the day, how to create a rich ecosystem is one of the main roles and challenges that digital innovation hubs have in front of us. Apart from the generic digital innovation hub definition, there is at the moment the European network of digital innovation hubs. That this network is actually creating a sort of top grade facilities that can act a little bit as lighthouse, or they can be front runners in terms of implementing these advanced support services. From the digital innovation perspective, if we go back to this triangle of data, access, and value, what we see is that for the support of the SMEs, there are two main roles that testing and experimentation facilities or digital innovation hub could actually play in terms of warranting the quality and providing this business access towards the marketplace. If we try to follow and if we try to connect the testing and experimentation facilities, those are facilities that are basically at the service of SMEs to power applications like artificial intelligence in manufacturing. As we have seen, and I think John was mentioning this, data is actually the foundation of all those advanced applications. If we want to connect those data via data spaces, or if we want to build digital twin or artificial application solutions, we need to connect this ecosystem via testing and experimentation facilities. So the testing and experimentation facilities are actually critical in empowering our SMEs with the ability to access and to generate those assets of high quality. But at the end of the day, we have to create business opportunities. They have to test before they invest in specific technologies to run advanced services. So SMEs, they also need to rely on the services of digital innovation hubs that will provide access to skill, that will provide access to finance. And at the end of the day, they will complement the testing and experimentation facility and should allow this type of assets to reach the market. So with the combination of digital innovation hubs and testing experimentation facility, we can really create a sort of virtuous cycle from the raw data that we manage or we deal at the SME levels towards the type of asset that has value and it is prepared to be offered in a marketplace. And that is not just data, it's data with quality and that is fit for purpose. If we look at the current network of digital innovation hubs in Europe, what we can see is that when we focus in data and data spaces and this type of networks across Europe, what we have is obviously as a reference alliance is the data space business alliance that is basically bringing together the different assets and the knowledge of the main initiatives in Europe that are dealing with this. So VDBA, Fireware, ITSA, and GaiaX are actually building these hubs that should focus in providing this type of support to SME. So today, what I'm just very briefly introducing is how one of these hubs that is serving the whole Iberian Peninsula is starting to provide the first steps in making sure that we can mobilize and support the generation of high quality data that can support the operation of data spaces for deployment of artificial intelligence and digital twins in Industry 4.0. So by data, that is this initiative, an association that is trying to connect the business with this value of the data economy that I was mentioning before. It is actually an initiative that was initially triggered by IDSA, but now it is actually one of those initiatives that is supported by the SBA. And where do we place and where do we locate this by data ecosystem development to support the build-up of this European common data space that we are trying to build? I think by now we are all familiar with this map of different initiatives at European level. With the creation of this ecosystem, what we are trying to do is to make sure that we add a specific layer that is connected with the access to data assets of high quality. Basically, the initiative of Bydata is to make sure that we mobilize the necessary stakeholders in an ecosystem to realize all these added value applications, data spaces, digital twins, and artificial intelligence. And we do this basically following three main three main pillars. And I'm very happy that David actually selected the coffee beans example, and then our colleagues from the Supercomputing Center in Barcelona follow up with wine, because what we are trying to make sure with this lower layer that we connect with data quality is actually to make a distinction between a very nice espresso and a very nice bean. So one may have a nice bean that potentially can generate a very nice espresso, but we have to put all the elements together, that we have enough beans and that the coffee that we make is actually of good taste. So the first pillar of ByData is actually to work with the companies, with the support, and in collaboration with digital innovation hubs, to make sure that SMEs can actually transform their existing data sets into data assets. So they treat this type of data assets more than as a data, they treat this more as a product. The second pillar that the community is actually building upon is that once you have this data asset and you want to put this into a marketplace, you need to exercise data usage control, what we already know as data sovereignty. And this is essential because this protects the use of the data, because now it becomes a product, it becomes an economic asset that can be valorized. Maybe even monetized, as Stefano was suggesting. So the idea of the initiative is actually not only to push the data quality, but to introduce data usage control to protect the use of this economic asset. And with this, actually, we can approach the development of data spaces as based on international open standards. So we can create this necessary trust to unlock either synthetic or real data across ecosystems and companies. Which are the stakeholders that are behind this initiative? This initiative is really recent. The initiative kicked off just less than a month ago, and we are basically starting to bring the initiative forward, but already brings very interesting ecosystems together. Ecosystem like ports, ecosystems like aeronautics, automotive, logistics, mobility, smart city, smart tourism are actually ecosystems that already bring together over 600 companies. Even if you see only 30-something partners in the slide, behind those partners are ecosystems beyond 600 or even 700 companies that are already starting to look into how to mobilize the data. So this data should start building on quality, so we can later on really unveil the power of common European data spaces and artificial intelligence solution. ByData therefore has to support the four main axes that one need to support in terms of data mobilization, access to knowledge, innovation, talent, and the development of the ecosystem itself. That is actually the focus of the initiative. And for doing that, and probably since this is going to continue taking some other sessions during the data week this week, just for you to know, there are a complete set of activities that are going to focus in supporting the development of these value chains, in the support of the adoption of the type of technologies that the colleagues were presenting before. So in this way, we can actually mobilize the ecosystem that are approached and supported by digital innovation hubs. If you want to learn a little bit more about this initiative, this ecosystem building effort that we are starting as we speak, you are invited to join us on the 2nd of June. If you want to travel to Bilbao, you are more than welcome. But if you want to follow us in this B2Match platform, you can subscribe to the associated event that is part of the Data Week agenda. Thank you very much.
Thank you very much, Oscar, for the very, very comprehensive view that you have done, putting together a lot of things, of course, because it's true that there is a lot of meat to be cooked, but many things have been developed during the last few years for specific aspects, and now it's really time to put everything together and prepare the table for the business purpose at the end. Thank you very much. So with this last talk, we close the first part of the session. I invite Sergio to open the cam. He will provide some comments on the second part, that it is the panel. I'm now going to share in the chat of B2Match the link for Slido, the one that you can use to provide your view, to provide your feeling about what will be introduced by Sergio in a while. So, Sergio, you can
Good
start
morning.
introducing the session. Thank you very much.
Okay, good morning, everybody. This is Sergio Gusmeroli. I'm a research coordinator at Politecnico di Milano. And my role here is to moderate the interactive session of this Data Week event. I had some doubts at the beginning when organizing this interactive session, whether to address the very interesting technical and business and ecosystem issues and challenges that the previous speakers have pointed out, or to take a more general view and look at, in general, how the manufacturing industry could contribute to data economy, or better, how implementing data economy in manufacturing industry could be favored, could be boosted by initiatives, actions, and recommendations. And this is basically the aim of this interactive session. I have prepared some 3 questions in Slido, and you will have the possibility to give your opinion. And the questions are about what actions, what recommendations are you suggesting so that the manufacturing industry could really embrace, adopt, and make data economy essential in their business and in their competitiveness on the global marketplace. In order to be inspired by this, I had a look at one document issued by the Commission, which is called a Guidance on Sharing Private Sector Data in the European Data Economy. And it is an appendix of the communication towards a common European data space of 2018. And I was inspired by these 3 models, which could really change the business of the manufacturing industry. And first of all is open data, and especially how much, to what extent, and in which way can the manufacturing industry contribute to the open data movement. Second is data monetization, data marketplace, and I believe that there has been also some speakers before me who stressed this point, that is how data marketplaces could become a new source of revenues for manufacturing industry. And third is data exchange in a closed platform, usually in closed value chains in manufacturing. You see that there is a decreasing aspect of openness in the three options. In option A, you have openness from the supply and the demand side. In B, you have openness in the demand side, but the supply side is somewhere closed. And in C, you have closed both the demand and the supply side. In this respect, we have prepared this Slido. And the first question of this Slido is open data for manufacturing. And the question is, which are the factors, which are the actions, the recommendation in order to make the manufacturing industry protagonist in the open data environment. And I have underlined 4 main actions, and you can vote them in order to express your ideas. You can vote 1 or 2 options in this question. So, okay, I believe that answers start coming. So, first option is open innovation business models for manufacturing industry. This is a reality in many manufacturing industries, and especially large enterprises are promoting the creation of open living lab, of open innovation ecosystem, and they produce open data so that to feed innovators, and especially AI innovators in our domain, of course, and they promote awards, they promote challenges, they promote contests, so that they could create an innovation environment, an innovation ecosystem for their products and their production, but especially for their products, which goes beyond the borders of the company itself. So it is not just the engineers who are promoting open innovation, but also the consumers, the public, and in general, the open living lab. Option number 2 is Digital Innovation Hubs Network. And you have seen also Oscar mention this and introduce this concept. And the testing experimentation facility. There are a lot of data which are produced in this testing and experimentation facility, which are, okay, sorry. Yeah. Are we confusing things, or is it okay?
No,
okay. The order, okay.
Audience is coming.
The second is a testing experimentation facility in order to, there are a lot of data sets, a lot of data which are produced, and we need, of course, open standards. We need the way to make them fair and to open them up to an overall community. The third point I put is more in the advancement, in the technical advancement about techniques of anonymization, pseudonymization, and also synthetic data generation, as Federici was mentioned. And the fourth option is regarding models and tools for trustworthy synthetic data set generation for manufacturing. So I believe these are the 4 options, and votes are currently coming. And maybe if the speakers want to comment that at the moment, the open innovation action, the open innovation recommendation is the most voted one, together with the technological advancement about new techniques for anonymization and pseudonymization. If you want to comment.
Sergio, if I can intervene,
yes,
just to comment a little bit, at least from what I see in the slide at the moment, I think there is probably a stronger connection than the results at the moment show between the option 1 and 3, because one of the problems we may have, and I think you mentioned, and I think Federici also mentioned, that is the scarcity of data at the moment, because either the data is too sensitive to be shared, or the data is not there in the format that we need to create these ecosystems of innovation. So the testing and experimentation facilities, the digital innovation hubs, they represent a more neutral intermediate ground where actually we can create the beginning of this ecosystem. So even if I see a lot of connection and synergies between the first and the third option, because I believe without option 3, it would be relatively difficult to trigger option 1, or at least option 1 will be triggered on a very limited set of data or with a reduced ecosystem for starters.
Okay, thank you, Oscar, for your comments. Other comments from the speakers?
Just one comment that all these business models, for me, they involve additional actor. So just to put it simple, Sergio, I think there is a manufacturer, but there needs to be somebody else that will do the data synthesis or the data cleansing. So these are not typical, this is a layer of added value processing that will then feed into experimentation facilities, digital innovation hubs, maybe solution providers. Actually, another comment is that all of these things are happening in other sectors, right? But in manufacturing, it's probably a little bit more difficult because it's a conservative sector. It's not a sector, which is so much IT oriented. But in other sectors, some of these models are happening. Like, for example, healthcare, you can buy data for healthcare, for your experimentation or drug development. You can go just and buy, right, from somebody that cleaned the data, created synthetic data, so that you are having some good data to work with. But maybe the manufacturing sector is a little bit more conservative for this. And I'm saying this in a good sense, not necessarily in a negative sense.
Yes, we could go. You introduced also this question. The second question is about the data marketplace. And this usually requires the presence of a third party, of a mediator, who is organizing the marketplaces. Option number 1 is to proceed bottom up. That is to have some embryonic sectorial data marketplaces in some sectors, for instance, in automotive, in machine tool sector, in textile, which will be the pioneers in order to create a real business for manufacturing industry based on the data. Servitization is something which is quite usual now in manufacturing industry, and it requires, of course, data and data marketplaces. But the point of selling just data is something which is in its infancy. It is just embryonic at the moment. Option number 2 is the presence of industrial data platforms for data sovereignty. And so this is an enabler, of course, because we need that in a data marketplace, data sovereignty must be respected, the ownership of the data, and the confidentiality of the data. Then we have advanced AI-based models and algorithms for valorization and certification. This is something more not so technical, but the point is that in a data marketplace, I need to give a value to the data I put in the marketplace. And this value could also mean a monetization of the data. And which is the value of the data? We could have a value of the data which is just in the data sets itself, or we could estimate a value of the data also depending on the consumer, on the customer of the data. And this is something which is maybe more difficult and requires more elaboration and more sophisticated pricing system for data marketplaces. And the last point was business and governance models of these marketplaces. This is quite a delicate question. And what John also said, so maybe we need a third party. And this third party, this data platform, this industrial data platform provider, would need to have some very clear business and governance model, especially regarding confidentiality and competition. That is to create some precise workflows and rules in order for the data marketplace to be assessed by competitors or to be assessed by unwanted data providers. So I see that now the most relevant option is the option regarding data sovereignty principles. Nenad, you wanted to comment?
Yes, actually, like Oscar, I would combine this first and last. By the way, I think that this interaction with the audience is great, and we see really a lot of fluctuation. My comment is this first is look, first of all, we have the problem in the manufacturing domain that people or companies don't want to share the data. Simply, it's a problem. Why are we sharing the data? And now, when I'm looking into this, okay, there will be a marketplace, and the most of the audience is saying the data sovereignty is very important. So what will be happening with my data, which is absolutely great. But on the other hand, this data has extremely huge value. So I would say this last point here in the ranking list, how I'm actually knowing what is my data worth. So I would say not only that I have to be sure that no one will be misusing my data, but also that I will be, let's say, paid according to the value of my data. That would be very interesting to be developed in the future, because because manufacturing and all these business entities are obviously value driven. So if there will be the way for saying, look, in the marketplace you can share the data with a high sovereignty, and also you will be valorized on your data according to some rules, according to some criteria, I would say that will be open a lot of opportunities really to sharing the data, and then to be even more motivated to share the high quality data. This is also an issue when we are talking about the data, that we don't need to share something which is really bad data. I was talking about this data quality, but also we have to motivate companies to share high quality data. Thanks.
Okay, thank you very much. Any other comment, Fenelity?
Yes, so what I would like to bring forward is the dimension that we're talking about data monetization in order to try to provide incentives to the different manufacturers to share their data, but we should have in mind that there could be cases that they would opt and would be more convinced to invest on a bartering option more. So I am going to offer those data, but in exchange, I need this type of data from you. So instead of waiting for monetary compensation, they are waiting to get data they don't have right now that would bring added value to their own operations as well. So I think this could also provide an extra incentive to manufacturers that would answer that I don't care about monetizing my data. Yes, but you can get additional data that you don't have access right now by opening up, exposing your own data.
Okay, John?
Very good point, Fenareti. Just two comments, I think, which are important in this slide. I see that you know, the third option didn't do very well, but for me, it is the most natural evolution of what we already have in manufacturing. So we have supply chains, private industrial networks, where stakeholders from a specific sector, like automotive, they meet, and this is a private data space. Well, it's not called a data space because it's a new term, but this is how it works. If I am in the automotive sector as a supplier, I can join a private industrial network on an industrial exchange, put my catalog, and be able, to sell my products to other stakeholders in the automotive supply chain. So for me, this could be the most natural evolution to the data marketplace idea. So we don't have, a data marketplace that it's manufacturing in general, right? But it's a specific sector. We are relevant stakeholders. We are on the same value chain. So this bartering thing that Fenareti mentioned can happen, because I have something from the value chain that I can give to somebody, some data, and then take data back. So this is one point. This option didn't do very well, but for me it is promising in the manufacturing because it's evolving what we already have. And the second point, I don't know if it's better for the third part of the poll, but I think beyond the classical, because all the things that we saw on the first card and this second card is the classical view on how to monetize data, like do a data marketplace, and this you can have in every sector. I think that in the future, manufacturing can provide some great opportunities for new business models, entirely new business models, like asset as a service. Like if I'm a machine builder, I give a utility model on my machine based on the data of this machine. And this is an entirely new model where you don't buy the machine, but you actually lease and you see the data. Or if I am a product designer, I give you the 3D model for you to print, and I'm selling to you in a trusted way a 3D model. And these are unique to manufacturing because they do not relate to anything else that is happening in other sectors. And sorry for talking too much.
Yes, Stefano?
I think Oscar raised it before. You want to go, Oscar?
Just to reinforce, Sergio, what John and Fenareti was saying, that I think probably talking about manufacturing data marketplaces is too broad. And if we think more about specific value chains and their needs, either by because exists a regulation and a problem that could be effectively solved sharing data. Because at the moment, I think probably regulation or big companies just setting up some standards or at least a code of conduct could be the most promising way to unlock this data sharing issue. Either external regulation that force industry to organize efficiently. Obviously, that is something that must be done. So industry will organize to solve the issue in the most competitive way. But at the same time, I think if some key stakeholders that are dealing with these value chains, if they start providing this code of conduct that could be extensions of the document that you were showing at the beginning. I mean, that was a first guideline by the European Commission, but this needs to be adapted into a specific code of conduct. I think with that, we should be in a better position to create the type of ecosystems that we all have in mind.
Okay, thank you, Oscar. Stefano?
So I think it's important. I agree with what has been said. Was part also of my speech, also the bartering parts. But I think that the main problem with the data marketplace is, especially for large data owners or data creators, to understand why it's a good idea to share. And this needs to be somehow application driven, because the point is that at the moment, what happens is that the large industry has data and will pay an SME or a couple of SMEs to do work with their own data. There is no reason, no point in selling the data, because what's the return for the seller? And for me, that is the sticky point. The return for the seller, it's money, it's not the main driver for the type of actors that are in manufacturing, especially. So how much you can gain from selling the data itself might not be relevant for your business, which is millions or billions of euros. But having a better system, having a better application, for instance, on your data, because you have shared your data with other players, and so the machine learning system of predictive maintenance or whatever is trained across 3 times your data. So the quality of what you get is better. It's one possible driver. So for me, the main point of the marketplace, it's a clear value proposition for the data seller. And that is still not for me, not well understood, not well presented, not well perceived for sure by the big data owners, because they don't see the point. It's not as simple as that. So the community needs to show them that sharing the data, it's a benefit for them. Now, several European projects, including the Data Pitch project, for instance, which was part, the EDI projects, which was led by engineering, I've tried that, but there are still lots of work to be done, especially for big players. That for me is key when setting up a marketplace. Otherwise, we'll never be understood the value and accept the technology, because there is no point from a business point of view.
Okay, thank you, Stefano. Sorry, Nenad, I presented the question number 3, and then you could comment.
Okay.
So the section number 3 is about closed ecosystems, that is closed value chains. And the first action is to promote data spaces for product lifecycle management, and in particular, the development of digital product passports. The second is add to cloud continuity storage and computational facility, which is more related to real-time production, and it is related also to Gaia-X and industrial IoT architecture. The third one is digital twins for value chains, and in particular for value chains in order to consider anomalies and broken value chains due, for instance, for events like the adverse events that we had to address in these times. And so also for resilience, for repurposing of the value chain. And the last point is multi-stakeholders AI data spaces, including their explainability models, which is what already was said by some of the speakers. That is, we don't just need to have data spaces for input data to AI, but also data spaces for the results of the AI computation and for the explanations which are associated to these AI computations. Nenad, Sina, one question. Can we also go 2 or 3 minutes beyond 11:30?
Sure.
Okay, thank you. So, Nenad?
Okay, I was actually, this is very, I have a general comment. You're very enthusiastic here when we are talking about sharing data. By being very involved in manufacturing industry, especially in the SMEs, I would say I should be very skeptical. So we really have to work on creating awareness that, as Stefano was saying, data sharing has a value. And I will ask actually Stefano now, in your slide, you show that in the project you have an experiment, and then there was a company which was using some data-driven innovation, but then when you wanted to deploy it on a large scale or something like this, they said, no, it is too risky or whatever. So what is is your comment? What is lessons learned? So obviously making pilot project is good. So we can do something for fun, but then when it is start to become part of the main business, then we say, look, it is too risky. It's the same with these data values, with the data exchange, that pilot project will be probably welcomed by the companies, but then if it's up to adoption, that we will have some troubles. So I would be interested in your comment about your own slide, why it was the issue.
The issue is exactly what you're saying. That was too risky because the value perceived, and that's why I stress the word perceived when I was. There is an objective value in doing something, but there is also the value perceived by the decision makers. And making a case to the decision makers is the most difficult things at the moment in the manufacturing domain, because they are happy to have the proof there, they're happy to evaluate it, but when it comes to, okay, let's go on large scale or operational scale, then is where they become conservative. Yeah. So matter of innovation culture. That's the summary.
Okay, thanks. Great.
Okay, thank you very much. I will stop sharing my screen and come back to the main session. Okay. Okay, very good. So, Davide, up to you to do some conclusions and to thank the speakers and the attendants.
Of course, I will keep thanking speakers because it's always the real added value that we can bring in this sort of events. I'm happy about all the presentations that we had because we had a very broad vision, starting from the initial talk by Carlo on the concept of quality applied to data, describing their different aspects, but also taking care of the technical perspective, the synthetic data, and about the provenance, the importance to track and to be sure about what you are elaborating and your results. And everything together is absolutely relevant for making business out of that. So also creating environments, ecosystems, as Oscar presented, they are growing. I don't want to say locally because of they are big local environments. They are very much linked to European initiatives like Gaia-X and the SBA, as he presented, and how Stefano pointed out that there are still a lot of doubt. There is a lot of uncertainty on how to progress from the business perspective. That's, at least from my point of view, at the end of the day, is the real driver, is the real objective. We do research in projects, we create prototypes, but at a certain point, they need really to scale up to reach a maturity level that is enough for the operation and for the production, and of course, for business aspects. Given said that, I would really thank all the audience to stay some minutes more with us, you, Sergio, and all the support from the BDVA office that is enabling all the time to have these events running smoothly. Thanks a lot. And I guess now we have a closing video to say goodbye to you all. Bye-bye. See you hopefully in Naples. Ciao. Ciao.